So the next talk by Tim Newman is on, we call RFEs or radio front ends. As much as we can do with Uni Radio as the software processing part of software radio, it's the access and the availability of these front ends. We've been talking a lot about usurps because of our history and our collaboration with Edis, but there's a lot of different SDR front ends and transceivers that are out there on the market that are affordable from many different guises of affordability for home hacking to really kind of professional level installations and research and development. So we're going to see kind of a handful of, I don't know, everything that's going to go over. Generally speaking, things that are available to be used directly with Uni Radio kind of out of the box.
Yep. All right, so SDR transceivers is what I titled this, and like you said, I'm going to do a brief overview of just, a plethora of different receivers that are available to us, mostly focused on ones that have some sort of new radio source sync support. I'll start with a disclaimer because there are so many. I will not cover all of them. It's going to be tough and a lot longer time needed to cover them because there are so many. That's a good problem to have, right? Statistically, I think since I started this talk, actually, Michael Osmond already started a Kickstarter receiver and is ready to go. That's probably why he's not here right now. So the point is, I'm not going to cover all of them. But I'll try to cover the main one that you guys have probably heard about. And I'm not endorsing anything. It's kind of just a brochure of different receivers that you can use. Hopefully, many you haven't heard of before. So what would Uni Radio be without, radio front ends? Most likely we'll have, at this point, we'd have the most highly optimized, multi-threaded dial tone app known to man. A lot of us cut our teeth on that, using it and trying to figure out, how to actually write a block. So, but the point is, they've really advanced kind of where Uni Radio's gone. We wouldn't be able to do a lot without it. It's fairly obvious. This was stolen from Tom last year, and it's still actually a little bit dated, but this is showing the mailbox size of the Uni Radio mailing list, basically, and just showing some key points in it. Approximate release of the usurp, when most people kind of got their hands on it. You can see people are getting excited, more and more people are getting interested in it. People started looking at the RTL when that came out. That was a huge spike in it. So again, it's just going to the point of, our front ends really, work well with Uni Radio is what is really pushing everybody to do this stuff. So some more of the evolution here of this stuff. It's more of a historical thing, but I found it to be pretty interesting. So the bottom is more of the frequency range that the RF front ends are going to cover. How many people have used the basic TXRX or the usurp 1? All right, not too many people. We'll start there. In 2004, when that came out, you can see it was a small coverage. That really, people got used to aliasing, and you really learned a lot about that when you used the basic TXRX. And then, again, at the beginning, obviously, a lot of these were usurp as daughter boards. There's the WBX. You can kind of see it's expanding a little bit more. The Epic Bergs came out. SBX. There's the RTL dongle. Kind of your really first, really low-cost receiver. Obviously, support came available for that. You got the Pico SDR. The Hack RF, the first kick-started receiver, came out and covered a wide range. The widest range so far. CBX, Blade RF, another kickstart receiver using the line chip. Then you start seeing the ADI chips pop in, and just the coverage is pretty wild from then on. So this here now we're getting more evolution towards the buses, right? There's my very simplistic, as opposed to just a radio diagram before, but you got the RF side of the bus and then your host side, and again, just the evolution here of kind of the support for the frequency bandwidth that these RF front ends are able to provide to us. And here I'm assuming 16-bit I, 16-bit Q. Obviously you can get more if you go down to 8-bit. But I'm showing here kind of the max bandwidth that these buses are going to be able to support, starting with USB 2.0 all the way down to, yes, there's a potential one to have Thunderbolt here in the future. So now obviously the question is what host is going to be able to consume all this and actually do work on that. This is a whole other question, not our problem. So let's start with some of the obvious ones, right? The EDIS devices, the B200s, the E300s. Obviously, the E300 is the all-in-one, and the B200s, 2Xs are the kind of all-in-one solutions. Most people are well aware of these, so I'm going to kind of skip through these. The B200 was interesting because of the USB 3.0 port that kind of picked up the amount of bandwidth here were maximum line. You got the daughter boards, the newest one, the UBX, huge range there, and it's actually shielded. So that was good to see. The CBX, SPX, WBX, again, I'm assuming a lot of you guys are familiar with all these. If not, they're obviously show up there in the EDIS booth. DRS has the Pico Flexor. This is less known obviously than the EDIS one, but a lot of people still use it. It's got a wide range. It comes with an option to extend it up to 12.4 gig. It can do 2 channels. It's got OMAP on it. They do provide getting radio support. I think they're not up there yet. They do have a booth up there, so they are a sponsor, so it's good. The Epic has a couple different devices. They have the matchstick and the sidekick. This was an interesting one because it's a small PCIe bus, super small transceiver, but wide range, large bandwidth, 2 channels, space coherent. Then of course the RTL dongle, which most people can easily get their hands on because it's so cheap. Somewhat, obviously the parameters for this is going to depends on the part that you actually get. In general, the frequency is going to range between 25 and 2100 megahertz. Resolution and dynamic range aren't that great. Instantaneous bandwidth is small, but it's something to play with. Something to get your hands dirty. Newman TRX, that's kind of focused on, it's one application, it has many applications obviously, but focused on OpenBTS and running UPS and base station. That I believe uses a line chip also, so very similar parameters as the other ones that use a line chip. Kickstarted receivers, first one being the Hack RF, that's Mike Osmond's receiver, that's just if you're interested. The amount of money that they got for kickstarting that, and that was well received and well done. He did use I think a Maxim chip and then some other chip in there, not the Lime. The Blade RF did use the Lime, it's another Kickstarter receiver. So again, 300 meg with 3.8 gig, 12-bit resolution, 2 channels, USB 3.0. And then kind of the newest one, I don't think there's any radio block for this, but I thought it was interesting. A newer Kickstarter one called the Portable SDR that's geared towards shortwave and HF ranges. I think it's possibly still in the funding stages right now. It's got a little cool LCD color screen on it that shows live spectrum, which I thought was neat. 4 channels. How many people play with 4-channel radios? Anybody? A couple people? Okay. Well, we got the quad radio. That's the EDIS, obviously for receive channel. Facebook here uses 10 gig, 2 10 gig interfaces to pull those samples out to the host. Another less known one is the Silver Palm SP830 something. They have lots of different options. This is where the Thunderbolt one comes in. And I'll say if you want more information on this, you just come to me afterwards. I'll give you Google, whoever you want to find information on, will be easy enough, but I can give you more information no matter what. But again, 4 channels for this Silver Palm device, 300 meg to 4 gig. They have 1 transmit channel also. You can get a version with that. You can order different options, USB 3.0, PCIe, 10 gig, or Thunderbolt. I don't think that's out yet, but I believe they're working on that. It's small, kind of like a paperback book size. Then I don't have much experience with this one, but the Pico SDR, again, can be combined to get up to 4 channels. I think that Marisoft, they've licensed that software. You can actually run a LTE base station on this equipment, but it can do up to 4 channels also. So interfacing with getting radio. So, all these typically have to have their host driver, right? And then these are then wrapped in getting radio blocks to provide a source or a sink. For the DRS driver, that's their GR Dubry, not sure how to pronounce it. And of course you have BAS and Osmocom, UHD, and Sidekick computer radio blocks. Now, the interesting one is the Osmocom, obviously because it's kind of like a meta block for a lot of these devices, and it's the closest we have to kind of the all-in-one radio front-end block computer radio. Supports the RTL, Blade RF, PAC RF, TRX, OneQ, and of course the UHD devices. So, quick and sweet, again, just kind of a brochure. This is a homage to last year's presentation with Muppet Tom asking or prompting for any questions. But again, hopefully pass on a little more knowledge for those who are familiar with Thunderbolt devices, 4-channel devices. Maybe to solve something new. But if you have any questions on specific devices, again, we're seeing out there, they'll be around. But any other questions right now? Yep.
So what do you think you're going to have 10 years from now? I mean, 100 gigabit Ethernet is available, multiple gigabit DACs, entities, and
so I think a lot of it will be pushed by kind of, go back to this. Right, so where are we going to, one interesting thought is how far is our center frequency or our frequency support going to be pushed up? I think a lot of that will be pushed on international standards, 5G. I mean, what are people going to be, what's the academic community going to be researching in the next 10 years? Is it going to be 5G stuff in the microwave band? Is it, you're already looking at the massive MIMO kind of research going on at Loon. I mean, are more people going to be doing that? Is it just going to focus on lots of different 10 elements all tied together? I mean, that's a good question. I wish I could give a specific answer, right? But I think a lot of it will be geared towards whatever the industrial cellular community might. That'll be one driver for it.
Is your new radio keeping, is there kind of like a first law for SDR that says we can process 200 megabits per second?
So, right, so that would be, I mean, that's obviously dependent on the hardware that the new radio is running on. They try to keep up with things like being able to, run multi-threaded, to keep up with stuff, and taking advantage of all the different capabilities that new hardware will have and placing the hooks in that. So, I mean, I think they've been doing a great job of keeping up to that. I mean, all the multi-threaded per block support went in a long time ago. I mean, yeah, all the SIMD stuff is really also the major push, so keeping up to date on new SIMD instructions and keeping that pushed into the latest code base is really what pushes and drives the capability of that.
I'll put a plug in. We'll talk more about this tomorrow at the full dev conference because we've got, we've formed these working groups for Good Radio to kind of attack specific areas of heavy interest and of high difficulty. One of those working groups is our Volt working group. So that's dedicated to learning more about processors, trying to integrate more SIMD code expertise, expand the kernel space of what's inside Volt so we can do more math stuff. The other one, though, is the coprocessor working group. And I think coprocessors are going to be a huge help when dealing with really high speed and very complex data signals. Like, for instance, one of our Google Summer of Code projects from last summer was a student working on the TI Keystone 2 processor system on chip. And one of the things that the Keystone 2 has is a hardware FFT unit and a hardware turbo product code decoder. Because a TPC decoder is a really heavy math operation to do in a CPU. So if you can offload it to a coprocessor that's dedicated to solving that problem, that's great. That's something that you should take advantage of. So, and then if you don't, we also want to get software, right? So we have the flexibility. We keep experimenting with this stuff and we keep improving it. But if you have these coprocessors to attack specific areas of heavy bandwidth or CPU utilization, let's see what we can do as far as the kind of offload.
Could you say a little bit more about new blocks for the 4-channel radios? I mean, MIMO is kind of obvious, but with RF convergence and all, can you do radars with that or other nifty things?
You mean like so?
New radio blocks that are coming along, libraries and stuff.
That's important. So what would happen is usually like Silver Palm would release, right, the new radio source block for this 4-channel receiver. I mean, just like UHD does. And then at that point, after that block, I mean, there's nothing else special, but, so you have your own blocks that, just your normal getting radio blocks that are gonna do whatever they want to those channels. I mean, whether it be, like you said, whether it be some sort of beamforming, like apps or, massive, I mean, I don't think there are many apps out right now that actually support that. I mean, Ballin just showed some beamforming apps with the quad radio, I think, a couple of years ago. But there's not many specific blocks that, are taking in 4 or 8 elements and doing something with it that are out there.
Yeah, not really, but that does give me a launching point. Again, new user today, try to explain a little bit about the project. One of the things that we've talked about is this in-tree concept of what comes with getting radio, these library blocks, you get this massive amount of information and stuff just out of the box when you get the source code, and then there's this out-of-tree concept. And we'll have a talk on C-Grant and this out-of-tree concept. One of the main differentiations between what goes in-tree and what stays out-of-tree tends to be how general of a signal processing concept is it. So if it's very general, matrix multiplication or just complex multipliers or complex dot products, belongs in getting radio. Why not share that with everybody and have everybody on the same page with highly optimized code? If it's something very specific to LTE or GPS, those waveform specific or very application specific stuff, that's where we go to the out-of-tree stuff. And sometimes it starts as out-of-tree and we try to pull it in as much as possible. I think we've seen and we've heard of a number of people doing MIMO and beamforming and those kind of things on their own using getting radio. I believe that we can find general purpose concepts within there that we should pull into getting radio eventually, especially as we start getting these multiple channel devices more accessible and more heavily used. So I see that as something that we will be pulling in the not too distant future, if not very near future. Anything else? All right, cool. Let's stay tuned.